Hello everyone, and welcome to part 3 of our video on the AT32 CAN FD Peripheral. This part will talk about time stamping and TTCAN mode. Let's turn to the CIA 603 timestamp now. The CAN in automation CIA defines in specification CIA 603 a method for time stamping with at least 16 bits. It can be used in addition to TTCAN or stand alone. The basic concept of CIA 603 is to have a free running timer which counts clock cycles and not CAN bit times. The precision shall be at least 10 ms 16-bit or 1 ms 32-bit or more. Because the timer underline CLK may be asynchronous to CAN underline CLK, then the acquired time stamps depend on the relation of these both clocks, and there will be a delay because of the CDC. As shown in this figure, after an event, a copy of the timer is taken. This is the time stamp. This timestamp is stored into RTS or TTS, respectively, where it can be read by the host. After it is stored, a handshake signal announces the completion of the action. Timestamps are acquired at the sample point of SOF or EOF bit where the frame is taken to be valid. This can be selected by the configuration bit TSPOS. A frame gets valid for a receiver at the last but one bit of EOF, but for a transmitter at the last bit of EOF. Register bit TSEN enables or disables time stamping. If disabled, TTS and RTS are 0. An external timer needs to be used for CIA 603 time stamping. The external timer shall be at least a free running counter that increments with timer underline CLK. For our AT32 F45X series, the external timer for the CAN controller can be selected by the SCFG underline CFG2 register. The bit width of the external timer is up to 64 bits. If the external timer has less than 64 bits, the unused bits of TTS and RTS shall be filled with zeros. Let's look at time-triggered CAN, also known as TTCAN. TTCAN is an operation mode according to ISO 11898-4 in which frames will be transmitted only at predefined time window. There are 3 time window types. First, exclusive time window. Only one node is allowed to transmit one frame with a specific ID. Second, arbitration time window. Several nodes may transmit a frame and arbitration takes place. Third, free time window, reserved for future extension of the network. TTCAN is defined offline by AT32CAN system administrator and organized in a system matrix as shown in this figure. A row is referred to a basic cycle, and it starts with a reference message. The reference message is transmitted by the time master. Other messages can be transmitted by any node. After the reference message is received, the cycle times of all nodes in TTCAN system are reset to 0 by hardware. An internal 16-time time counter starts then counting upward, in sync across all nodes. The time of the SOF of a message is a sync mark. The sync mark of a reference message is the ref mark. Timing is done by a free-running 16-bit timer. The difference between the timer and the value of the ref mark is the cycle time. Each basic cycle starts from the cycle time at the ref mark. The cycle time is stored in the RBUF as a time stamp. If TTEN is set, then the 16-bit timer is running. If a reference message is detected or if a time master successfully transmits its reference message, the CAN controller copies the sync mark of this message to the ref mark, which sets the cycle time to 0. After a reference message is received, the RIF is set. The cycle time of the reference time is 0 in RBUF. TTCAN bit time can be divided by setting the TPRESC bit. There may be up to 8 potential time masters in a CAN network. Each one has its own reference message ID, the last 3 bits of the ID. Potential time masters may try to transmit their reference message according to their priority. Lower prioritized time masters shall try to transmit their reference messages later. As shown in the table below, the reference message ID can be configured using the RefMSC register. The CAN controller has a window trigger. It is used to check if the time since the last valid reference message has been too long. If the cycle count equals to the value defined by TTWTRIG, then WTIF is set. If TTWTRIG is updated, and it is lower than the actual cycle time, then TEIF is set. Valid write access to the TT trig activates a synchronized data transfer from host _CLK to the CAN _CLK, which also activates the trigger. If the trigger is activated, the TT_trig write protection is also enabled. Only when a trigger time is reached, TTIF is set, or a trigger error occurs, TEIF is set. This write protection is disabled. Here's an example of how TTWTRIG window trigger time. Bit rate 1 Mbps. Timer prescaler is 8, then 1 tick equals 8 microseconds. In this case, if TTWTRIG equals 30,000, the actual trigger time is 30,000 multiplied by 8us, which equals 240 milliseconds. The maximum value of window trigger is 65,535 multiplied by 8 equals 524. 28 milliseconds, which is 524.28 milliseconds. Taking this diagram as example. First, set TTWTRIG equals 30,000, configure the reference message ID as 0x06543210, and set TTEN to start the timer. Second, send a reference message which resets the cycle time to 0. Third, when the cycle time reaches 30,000 ticks, 240 milliseconds, the WTIF flag is set. Fourth, if TTWTRIG equals 20,000 is set, which is less than the current cycle time, then the TEIF flag will be set. The behavior of TBUF depends on the TTTBM bit. First, this mode is selected if TTTBM equals 0. In this mode, it provides a combination of event-driven CAN communication with timestamps of received messages. The PTB and STB act similar to when TTEN equals 0. This mode is suitable for time-triggered TTCAN type. 2. If TTTBM equals 1, the PTB and STB are both used as an array of the TB slots of the same transmit buffer. Each slot can be addressed by TBPTR. Here is a flowchart of data transmission from TBUF slot. First, use TBPTR to point to a slot in the transmit buffer. If TBPTR is 0, it points to PTB. If TBPTR is greater than 0, that is, from 1 to 3, it points to a slot in STB. Next, use TBF and TBE bits to mark a slot as either full or empty. A slot marked as full is write protected and can be sent. Finally, use the trigger pointer TTPTR to select a message slot to send. All transmissions can only be started using a trigger. When a trigger event is detected, the selected message is sent immediately, and an interrupt is generated to signal the host that the next action needs to be prepared. In addition, PTB has no special properties in TTCAN mode and is associated with the STB. All status flags related to PTB, such as TPIF, are ignored. Instead, STB-related flags like TSIF are used and will be set when the frame is successfully transmitted. TBSEL, SNEXT, TPE, TSONE, TSALL, and TPA are not meaningful in this mode and are ignored. To abort a transmission, you can set the TS a bit. For TBUF in TTCAN mode, here is an example from our BSP. First, define the data frame to send. Then call the function to write into one TBUF slot. Finally, write the trigger time to start a trigger. Upon a trigger event, data will be transmitted. This table summarizes TTCAN trigger types. There are 5 trigger types. Taking a single slot transmit trigger as an example. Single slot mode is selected by TTYPE. It is automatically used regardless of the state of relim, including relim. After a trigger is started by setting the TT trig, when the cycle time is equal to the trigger time, A single slot data transmission takes place, no transmission if trigger error. TTIF will be set under the following conditions: TTPTR points to a full buffer slot, and the cycle time is equal to the trigger time TT-trig. TEIF will be set if trigger error occurs. These errors include: the TT-trig trigger time is lower than the current cycle time. TTPTR points to an empty buffer slot while cycle time equals to the trigger time. For TTCAN trigger types, there are several points to be emphasized. First, for single-shot trigger type, the ISO 11898-4 defines a transmit enable window of up to 16 ticks of the cycle time. The register bit TEW+1 defines the number of ticks. A frame cannot be started if the bus is occupied by another frame. This should not happen in an exclusive time window, but the transmit enable window ensures that there is no delayed start, which would result in a violation of the next time window. If the transmit enable window closes and the frame could not be started, then it is aborted. As a result, the TBUF of the frame will be marked as empty and AIF will be set. Second, a time trigger can be used if TTTBM equals 0. This is the only trigger type which is available in this mode. If another trigger type is started, writing TT-trig, TEIF will be set. In order to ensure the normal operation of other trigger types, TTTBM equals 1 must be set to enable trigger the data transmission. When TTTBM equals 0, a time trigger type is suitable for PTB or STB transmission. Hint: STB or TBUF must be empty when operating TTTBM. Third, a transmission can be aborted using TSA. TPA has no meaning. After aborted, the buffer slot of the frame is marked as empty by hardware and the AIF will be set. First, let's look at the immediate trigger. This trigger type is selected by setting the TTYPE and setting TTTBM equals 1. From this figure, first configure TBUF, write any value to TT-trig. You will see that a data frame is sent immediately with no ACK response. With no ACK response, this data frame will be sent repeatedly. This data transmission can be aborted using TSA. AIF is set accordingly. The TBUF of the frame is then marked as empty. If another value is written to the TT-trig after TBUF slot is cleared, TEIF will be set. Here is another example of the time-triggered type. Select time-triggered type using the TTYPE and set TTTBM to 0. See this figure. Set TTEN to enable TTCAN timer. First write TT-trig equals 10,000 and then update it to 20,000. Actually, only the first value will take effect since TT-trig is locked. In this mode, you can send frames using either PTB or STB. When the cycle time reaches 10,000 ticks, which equals 80 milliseconds, the time trigger interrupt flag TTIF will be set. If you write TT-trig equals 10,000 again, while the current cycle time is already beyond 10,000, then the trigger error interrupt flag TEIF will be set. Here is an example for the single-shot trigger type using transmission enable window TEW. If TEW equals 0, the window duration is 8 microseconds. As we can see, first, after enabling TTCAN, set TTYPE to single-shot trigger and write TT-trig as 20000. Second, when the cycle time reaches 20,000 ticks, which is 160 milliseconds, the TTIF flag will be set. Third, if the CAN RX pin is manually pulled low before TTIF is set, the bus gets occupied. If the duration of occupation exceeds 8 microseconds, the frame will be aborted, the TBUF slot will be cleared, and the AIF flag will be set. If TEW is 15, then the enable window time equals 128 microseconds. After enabling TTCAN, set TTYPE to single-shot trigger and write TT-trig as 20000. When the cycle time reaches 20,000 ticks, or 160 milliseconds, the TTIF flag will be set. If the CAN RX pin is pulled low just before TTIF, but the duration of bus occupation is shorter than 128 microseconds, then the frame will still be transmitted successfully. Finally, let's have a look at transmit start trigger and transmit stop trigger. They are used for arbitrating time windows. Write a frame into any TBUF slot and mark it as full. Set TTPTR to point to this TBUF slot. Here is the process. First, use TTYPE to select transmit start trigger and write TTTrig as 20000. Second, when the cycle time reaches 20,000 ticks, 160 milliseconds, TTIF flag is set and the frame transmission takes place with no ACK response at this point, so the frame is being transmitted repeatedly. Third, use TTYPE to select transmit stop trigger and write TTTrig as 40000. Fourth, when the cycle time reaches 40,000 ticks, 320 milliseconds, TTIF flag is set. If the frame is still not transmitted successfully at this time, it will be aborted. The TBUF slot is cleared, and the AIF flag is set. Fifth, if TTPTR points to an empty TBUF slot, when the transmit start trigger time is reached, both TTIF and TEIF are set. When the transmit stop trigger time is reached, only TTIF is set. When it comes to configuring TBUF slot, the procedures are as follows. First, set the trigger type bit TTYPE to transmit start trigger, and then write the trigger time TTTrig as 20000. Second, when the cycle time reaches the trigger time, which is 20,000 ticks or 160 milliseconds, the time trigger interrupt flag, TTIF, will be set. Then the data frame transmission takes place. Since there is no ACK response, the frame is transmitted indefinitely. Third, when the cycle time exceeds the trigger time and reached 40,000 ticks, or 320 milliseconds, set the trigger type to transmit stop trigger and write TT_trig as 40,000. At this point, because the value written to TTTrig is lower than the current cycle time, a trigger error interrupt flag, TIF, will be set immediately. The system will then automatically abort the transmission, and the abort interrupt flag, AIF, will also be set. That's all we have for CAN FD Peripheral. Thanks very much for your watching.